So Andrew, once again, if you could just say a one sentence who you are and welcome us all to the presentation.
Okay, well, yes, as Dan mentioned, I'm Andrew. Thank you for having me here to talk to you all today. And hopefully what I'm going to talk about is not too far outside of the realm of what makes sense for all of you. Like digital within the arts and humanities and sciences has really sort of changed over the past 30 years. And basically, since I've been in college and now to teaching, I've been super interested in this. And so the work that I'll talk about today basically will cover some of my early work as well as stuff that I cover in the book. So it's a pretty broad spectrum of how digital technologies are changing my research, but then also the discipline of architecture. So I will share screen then and we can get going. Dan, I will try my best to keep on time, and so feel free to cut me off at any point if you need to, but hopefully it should be fine. I just have to find the full screen view. Okay. So everyone can see my screen, hopefully? Okay, awesome. So I'll just move on from here. So as I just mentioned, so in architecture, there has been sort of a really big move in terms of the move towards digital as well over the past 40 to 50 years. When I started college in 2011 at the University of Texas in San Antonio, I was really interested in understanding how the design process was going to be sort of transformed through the digital technologies. And especially for me, not being able to draw by hand, this was eye-opening for me because it put me in a sort of it put me in a good position for where things were going. But in architecture itself, and I'm sure the timelines are sort of similar in a lot of the disciplines, but in the 1970s, we began to see CAD, which is computer-aided design. Then in the 80s and 90s, we sort of moved to an era of what we can call digital design, which moved beyond just making floor plans and stuff in CAD and looking at 3D models in digital space. Then in the 80s and 90s, getting into virtual reality. In the 90s, getting into what is called digital fabrication, and that's actually using digital tools to begin to create physical artifacts. So taking a digital model and transforming it directly into architecture. And then beyond that, getting into the 90s and 2000s, parametrics and computation. So using computational formula, like mathematical formulas to design in models that are dependent on each other. Finally, recently in the 2000s and 2010s, getting into mixed reality making. So completely eliminating the drawings and through augmented reality, building in real space with a digital model applied to your vision. Robotic production, so making with robots in real time, to where we are now, basically getting into machine learning for design and making, and where we're sort of headed in the future, which is intelligent environments. And so that's sort of like an overview of the past 50 years of where digital has begun to influence architecture. And so we'll touch on a lot of these sort of aspects today in the talk. So a long time ago, and even now, a lot of this stuff it's still relevant, right? But in order to create complex forms, people like Antonio Gaudí would create models like this. So this is a hanging chain model, which basically shows catenary curves. So to create very complex forms that are structurally sound, Antonio Gaudí in the early 1900s basically used these chains that are weighted by with sandbags or different weights on them. Now, for instance, we can do all of that through interfaces like Grasshopper here on the computer, which runs through Rhino 3D, or through various sort of computational softwares. So there's been a big shift. The sort of thing we always see in movies when they talk about architects is the big sort of room filled with people with drafting boards. It's completely not a diverse room here either, right? So we see very this sort of thing, lots of people drawing by hand, lots of people that look the same, right? Now we've completely sort of switched gears on this. And so this is from a project that I worked on in using the Microsoft HoloLens as a means of building things without any drawing. So you actually see the things you're making right in front of you as you're making. We'll look at this a little bit more later. To sort of fabrication and construction practices, where previously you had to do these really dangerous jobs by hand. You could see this person here sitting on the Empire State Building as they were building it with the Chrysler Building in the background. Very dangerous, very waste intensive, very energy intensive, to things like this now. So this is the Block Research Group. This is actually a digitally knit concrete formwork, which they basically create the design. It's knit out of a single material, and then they stretch it into position on site. And basically they lay the concrete on top of this. And so you eliminate all of the complex formwork that existed before, eliminating waste, minimizing the amount of materials that you're using, and also like adding a new sort of dimension to it. And so the digital has really transformed architecture over the past 5 decades. Now, in all of this, where I kind of fit into this and where I'm interested, are looking at several sort of categories: form, material, computing, machines, and how they all lead to craft. And so we'll talk about a lot of stuff here today, but I think the most important thing to remember when we're talking is we're not talking about eliminating the human in any way. We're talking about augmenting the human to give the human new sort of potentials. So whether that's new efficiencies or new skills or the ability to make new things, that's what I'm interested in using these tools. So like as Dan has mentioned, I have talked and researched all over the world. I practiced in Japan for 4 years. I've done lots of work in China and all over the United States. That has been from traditional buildings using these tools, such as this project in Shanghai, to how I teach. And so I don't just teach how to make buildings, I teach how to make tools and how to rethink architecture through robotics and computation. I also write a lot. So Dan mentioned that I was co-edited the book Towards the Robotic Architecture, and my co-author from here, Mahesh Das, we're actually writing a new book right now called Being Human, Being Robot. So same as the title of this lecture. And as you can see from how young I was in this picture, many, like 2 decades ago, probably about now, I've been doing this for a long time. And so this was the project back in 2004 using a 60-foot long CNC fabric cutter, which basically built a new entrance structure for our architecture building, which was a really hideous building. And so we got funding to do something like this nearly 20 years ago, and it's still standing today. I've been continuing this sort of thread of research for quite a long time now, getting into robotics, looking at new materials such as carbon fiber and how you can use robotics to sort of make things, and understanding how these new materials can transform what buildings and craft actually, what built craft, what it could be and what it means for the people who sort of inhabit spaces. So the first part of this I will call Being Human. And it really looks at how digital tools are transforming the work that I'm doing. And not just in making, but I think the digital tools have also really helped us like rethink representation. And so in all of my classes and all of the work that I do, it's not just the artifacts that we make that are important or the process. It's also equally as important to be able to create new types of graphics that explain what you're doing. And so I spend a lot of time, especially with my students, having them figure out who they are as sort of graphic designers as well, and using new tools to sort of let those, using new tools to sort of grow their own abilities. This is also important for me, like beyond the graphics, but understanding how to represent every single element of a piece that is going to be made either through robotics or through CNC processes. So this is a table that I'm one piece from a table series I'm working on with a sculptor here in Philly. Also, just like new tools that we like graphic tools, either in like architectural softwares and outputting them to tools softwares like Illustrator. Things like that are like one sort of aspect that I think tie a lot of other things together. So art and not just the sciences, right? So we typically think of architecture as very technical, But the thing I always tell my students is if you're not having fun, you're not like, maybe it's not what you should be doing, right? And so we always try to have fun in everything that we're doing, and graphics are a way for me to really bring out that sort of fun. The other thing is craft. And for me, like crafting artifacts is more than just making a building, right? Something that I try to question through the tools that we have now is like, why do we even use the materials that we're using, right? Typically, when we're building something, we go to Home Depot or Lowe's and we buy like a piece of manufactured lumber, and you're sort of left with like something with flat walls that's very sort of predictable. But I work a lot with carbon fiber, which now you can sort of, through computation, you can model that to understand how the fibers will work. And what that allows you to do is not necessarily put together a building through surfaces, but really begin to think about what something could be through lines, through curves, through overlapping, and just creating a new sort of aesthetic through a new type of material. And so this was a project that I was working on with the friend Simon Kim in Boston. This was at the Autodesk build space. And then we brought my friend, the sculptor, Tim Rusterholz, into it to sort of sculpt these creatures at this, it's just a sort of like a demonstrator, basically looking at using carbon fiber for really lightweight structures and understanding how we could use them in a different way to create space. And so Tim worked on the sort of these sculptures that the piece sits on here. But there's something really interesting when you can begin to rethink the materiality that architectures could be built of. Not that this could be a building, but it opens the door to new ways of looking at materiality. Moving beyond just sort of craft becomes computation. And just like we looked at with Antonio Gaudi's sort of chain models, like in this pavilion that I had done in Indiana with some of our students, we were basically rethinking tensegrity structures through computation, which is pretty difficult. And so what a tensegrity structure is a structure that's held together in tension. So you have struts, and these compression struts are not allowed to touch another compression strut. So basically you have cables that support, suspend struts in space. And it basically comes together to create a volumetric structure. And this was the sort of end result of that. The previous one was a physical model, but what we looked at in there was basically how to sort of modularize that, or create a modular system based off of computation, which could allow us to predict how this thing could come together to create a new form and basically be skinned very quickly. So this project was designed and built within, so the design and build process took 2 weeks. The actual fabrication, the building of all the parts took 3 days, and the assembly on site took 2 days. And so the entire sort of building process took 3 days. We knew every size that every piece needed to be cut. When you have that sort of computational model, it's super easy to, right, just to move from digital model into physical space, which is really sort of helpful, especially in a project that's so complex where everything looks the same. And so the sort of aesthetics you get from that are also were also quite nice. And considering the short amount of time that we actually spent on this, it actually lived for more than a year. So that was unexpected as well. Moving from computation in my work goes to augmentation. And so how do you augment the sort of building processes through digital techniques? And so this is one of our collaborators on our project. He was a glass major, I believe his name was Dan, working on a steel bender. And so there's a software that we're using called Fologram that ties into the Microsoft HoloLens. And basically what that allows you to do is in design, have your digital model run the parts in your digital model directly into physical space. So that, for instance, we had several hundred of these unique bent pieces. We could flip through those like in real space and then see them visualized on that bender there, and then just bend away, right? So one piece at a time, switch to the next side, bend it again, flip to the next side. And basically what those pieces were these little sort of brackets that were sort of held together in this small prototype that we built. This is the sort of final piece. There was not a single drawing for this. It was all basically done digitally and then physicalized using the HoloLens. There was very little waste in this project also, because through computation, we were able to set a series of board lengths, and then basically optimize the entire system so that you don't waste any of the pieces as you're assembling it together. Through the sort of viewport of the HoloLens, or here through the cell phone, we're actually seeing the real artifact that we're building to scale within a room. Here it's just kind of thrown on a desk. But you can begin to see here where Alan here, he's basically, we're bending some of these steamed pieces of wood here. And although we can't see anything on the screen here, what Alan is seeing is where that board should be, where it should be screwed to, and he's basically directing us. And so this is the view that Alan is actually seeing. So in the making of these really, really complex forms, which would be extremely difficult to explain to somebody through drawings, because they're bent three-dimensionally in space, we're able to just in real time see that to scale on our platform and basically just bolt everything into place to allow it to dry and to fit, to dry out and to hold that curve that we want to make. And so again, this was the final piece. It took 2 days to build it. Not a single person had ever used the HoloLens before, except for Gwill, who was the Photogram person. We just threw it on. So most of the students were from other majors outside of architecture from within our art school. And like, we just went sort of nuts and built it in a couple days. So it was pretty awesome. And then Photogram basically took what we learned here to build this huge pavilion called the Steampunk Pavilion, which like the level of complexity in that is ridiculous. It's completely amazing. Again, not a single drawing in that. Another sort of interesting thing with when thinking about digital tools in design is beginning to misuse tools, right? And so just like the sort of representation part, for me, something that's really fun and interesting is misusing the tools and the materials that we're typically given to see what happens, right? Because we can make a digital model that's perfect and we can export that to a machine that makes it perfectly. But I don't know, for me, there's not really very much fun in that. It's more interesting to like begin to edit the code and mess with the tool itself as it's making to see what sorts of new aesthetics can begin to appear. And so these were just a few furniture pieces that I had pieced together from scrap lumber that I was given. And so we basically 3D scanned, or I 3D scanned all of the pieces of lumber, put them together, and then created a series of forms for a gallery in Texas. And then through sort of misusing the CNC coding in the milling process, actually began to create different patterns that were unexpected in the sort of the making process. So some areas will be extremely smooth, some will be very predicted in terms of like milling, in terms of milling marks or the residual marks from the CNC milling. And then others will be completely unexpected because through altering the speed of the machine in ways that it wasn't meant to sort of cut, you sort of got these really sort of interesting residuals that most people would typically just try to get rid of in the making process. So these tools, again, with all of my students, I encourage them not to just use the tools as they're meant to be used, but also sort of misuse the tools to see what can arise through the sort of misusing of a given tool. And so here you can see some of those details of how the machine with this like 10,000 pound machine was actually jumping as it was like cutting because the speed was too fast for the radius. Other things that we're beginning to do are embedding intelligent or like computers and intelligent systems into our projects as well. So when I first joined Temple, our chair, Rashida Ng, asked me to join her on a project called Cloud Magnet, which she had got funding for, was to create a series of kites that through fluid dynamic modeling, we could create a kite that could compress air into a cloud. We also use what's called the phase change material. So as temperature changed, it changed from a solid to a liquid, cooling the air down inside. And so this was a test bed project. It wasn't meant to actually create huge clouds, but bring attention to the raising cloud forest in Costa Verde, or in Costa Rica's cloud forest, sorry. And so these were some of the early studies that we had done, working with carbon fiber again. Through using digital tools, we're able to rethink how you can actually create a structure. And so this was a structure that I came up with where we wound just regular yarn first, or like this twine, wrapped carbon fiber around it so that it wouldn't slip, and then we would fire it in a kiln, and then the string would just come off, and you'd basically have zero waste in the process. But the important thing about this project is that we had to get it to Costa Rica, and it had to be like able to collapse. And so through using materials like carbon fiber and programming digitally density levels, we're able to collapse these kites down into something that's really small. And so these were about 6 feet long and about 6 feet at the opening at the front. And they were able to collapse down into like an 18-inch box, which was really helpful. And then Rashida in Costa Rica worked with the integrating of sensors so that we can see how much we're actually changing the air inside the kites. And then this was one of the kites here. The skin on the outside is actually impregnated with the phase change material that condenses and basically cools down the air. We obviously weren't able to make clouds, but we were able to get the temperature down to a range where now we could basically revise it again, change the design of the kite through computational fluid dynamics modeling, and go there again if we're ever allowed to travel and test it. But it was a super fun project that couldn't have been done without a lot of these digital tools. And the last sort of project that I'll talk about of mine before we get into looking at where robotics and more intelligent systems are going goes, again, another carbon fiber project, but looking at interfacing, right? So not only how do we change how we perceive buildings to be, but how do we begin to interact with them? And one of the things for me that's most interesting about like weaving a building together or winding a building together is the sort of aesthetics you're able to get. And so typically when we think about cutting a hole in a wall to let light in and put a piece of glass in there, we're very limited to what we like, the sort of aesthetics we get. But when you actually weave a building together or wind a building, you can really change the porosity. You can really begin to change structural aspects. You can do so much more that's really interesting. But on top of that, depending on what you do, so for instance, with carbon fiber, it can conduct electricity. Not as good as a wire, of course, but you can embed sensors into this as well, so that the structure itself can become like a living organism. And so this was a project called Rolypoly that I did with my friend Simon Kim and Tim Rusterholz, who the pair I always tend to work with. And it's just sort of it's a space for one person. And we developed a lot of new systems for how to make this when we were doing it. But the thing that turned out really interesting was the material qualities that we could begin to sketch out digitally, but then implement physically. So this is what the carbon fiber actually looks like. When you see the object, it actually reflects all of the light around it. So it gives a really sort of interesting aesthetic quality. And then when on top of the sort of aesthetics, there was also sort of, there were sensors embedded in it so that when somebody would approach it, it could sense you, and then it could sense your voice, and you could basically have a conversation with this thing. And so the conversation was really just a mix between lighting and sounds, but with carbon fiber being conductive, like in the first carbon fiber project we showed, we were actually able to run some current in there. So if you got close to it, you could begin to like actuate something like lights or speakers or something else, something that could basically begin to communicate back and forth with the sort of user. So sorry, that's a lot of stuff, but that is like what I am working on within the sort of digital realm of digital arts, design, and in science. Now, where things are going from there becomes even more sort of, at least for me, really interesting. It's very nerdy, but I think that where we're going in design is becoming quite fun at the moment. And so the next part of this is being robot, basically. And this is all based around what Mahesh and I outlined in our first book, Towards a Robotic Architecture. And so the first part of this is just understanding what a robot is, and what better robot than Bender to sort of talk about this, right? So a robot has to be able to think, act, and sense, right? It should have its own agency. It is physical and it is autonomous. And this is one of the sort of preconceptions within architecture where we tend to work with like robotic arms a lot, but robotic arms that are not autonomous and don't have agency and can't sense, they're just CNC tools, right? And so to get to a true robot within this, it has to have a lot more. And we're beginning to see in design, in architecture, more of this sensing and reaction happening now. Okay. So yeah, so I was saying from this standpoint, basically the robots in architecture aren't robots. And so one question is like, why is this important? And so like outside of architecture and design, we've seen like a really big shift in the past decade towards robotics and in artificial intelligence. And it's only going to be getting more and more, like it's embedded into our daily lives. In buildings, for instance, they create like a huge amount of the pollution that we have in the world, right? Either through construction, concrete production, waste production, like transportation of stuff from place to place. Like it's so bad. Buildings are so bad, right? And then you put an air conditioner system in there and a heating system, and you leave your doors open and windows don't open anymore. And they're just really bad. And so it's going to be really important now that we're sort of in this like deepening climate crisis, that we need to figure out how can we shift buildings in a way that they're not just like not doing bad stuff, but they're actually doing positive stuff to the environment. And the only way that's going to happen is through more intelligent systems. We see those all over the place now, right? Whether like Asimo is so old now, but like Asimo from a decade ago, or like in AI, looking at things like Google, or the oh man, sorry, my brain just stopped in here. But like using like image transfer and things like that, we're in neural networks where computers are beginning to try to figure out what it is that what they're seeing, what they're seeing actually are. And sorry, for some reason, my brain stopped on the name of the Deep Dream, sorry. And so like the sort of point here with architecture is we spend so much money on architecture. Your house, you'll be paying for 30 years, right? But the amount of intelligence within your house is so far below even what you have in your phone, right? And most people that are not me throw their phones away every year, every 2 years, right? And how is it that something that is going to be with us for so long and have such a great impact on the environment, how is it that it has no intelligence at all in how it's made and how it functions for the 100 years that it exists? And so that's a really sort of important question for me, that I think that these digital tools that we're getting into now can begin to help redefine the discipline of architecture for the better. And one of the interesting things with robotics, in a really dumb way, is moving from either making stuff on site, or what's called file to fabrication, where you design something, you send it off somewhere else, and it's built and then it's shipped, to what we can consider real-time making. And so you're designing and making at the same time. So in the augmented reality project that we had done with the big bent wood structure, that was real-time making. So if something didn't work, the digital model would be changed, and we would update that in real time. We're not talking about this, right? We don't want to automate architecture into a factory. What we could be talking about is something more like this at the ETH Zurich, where this person is basically drawing a line on the floor. The computer is seeing how that person is drawing the line in real time and building a brick wall digitally based on parameters. And then the robot is following behind that person, building that wall in real time. That is collaboration, right? We're not talking about automation. We're talking about like Rodney Brooks and high-fiving this robot here, or teaching a robot dyeing crafts so that people could learn later on how they could basically reintegrate these crafts into either through robots or through people in the future, or how we can create structures here, like by the University of Stuttgart, that basically what's happening here is this is a solar shade where everyone has a phone app telling how much shade you want or don't want. And basically these drones sort of reorganize the space in real time based on your shading preferences. And so it'll pick up these things, fly it to one part, and this will grow around you basically. So if you're like me and you don't go in the sun, you'll have like a big sort of umbrella around you. If you're like a normal human who likes the sun, right? Like maybe it's always like trying to like shade me and you're always in the sun. So super interesting potential. And so in robots within architecture, for instance, we typically think of like robots being like Curiosity and oh man, like the Mars rovers, right? Like they will obviously make sense when we are building on Mars and on Earth, like off like non-Earth sort of situations. But the thing is that like all of this stuff that's necessary outside of this planet, because obviously we're not going to send people to Mars to build their own habitats, they would not survive. It's all transferable back to how we think about stuff on Earth. And so over the past decade and a half, in architecture, we've basically witnessed like a full scale sort of shift from like hand drafting and like hand making to the integration of robotics and production tools. The other thing that's really different and interesting about all of this, so the digital tools are only part of it. The other part of it is that like it's also about collaborations outside of architecture. And so for us, or at least for me and a lot of others, we collaborate a lot more with people outside of the discipline. And we're seeing these tools moving from sort of like little sort of places with very few access to very few people to sort of access to lots of people, right? Because tools are becoming cheaper, they're becoming more accessible, and we're able to sort of get more people in on the whole thing now. And so they're like these tools are rapidly becoming indispensable within the discipline of architecture. And so we'll see this at the scale of the component all the way up to the scale of the urban environment in the near future. So it's quite interesting to understand how robotics will sort of transform architecture. And so real quickly, I'm just going to sort of run through some really cool projects that we outlined in the book that look at how architecture is basically being transformed by these digital tools. The first thing, just to sort of understand, is a framework that my co-author Mahesh and I were working on. So Mahesh basically broke this down into three sort of interaction frameworks. One, understanding how robots and humans interact within architecture. The next is like how do robots begin to transform the design process within architecture? So you obviously have different collaborators, whether human or non-human, collaborating together. And then also what happens when buildings become robotic, right? So is it a component? Is it a system? Is it a structure? Is it a space? Spatial robotics are kind of like the furthest in the future. And then like robotic components could be like an air conditioning system, right? It could be one little part of the building. And so there's a lot of ways that architecture could be influenced by robotics. Robotic production in architecture basically touches on what I've been talking about, using robotic tools and computational tools within design. And so there's so many things that are happening right now using in robotic production. And so this is a very old project from 2013, robotic bandsawing through by Grayshed. So you're able to use materials that you typically wouldn't be able to use, like a slice of a tree, because you could scan it and cut it super accurately. Creating really big projects with materials that you typically wouldn't think of. And so this is a project by Matter Design, where they hot wire cut foam using a robot to create this really, really tall, slender tower that's held down in compression. And so through using these tools, you're able to create things that would be very difficult to create otherwise. This is a really interesting project by the Architectural Association's Design Make program, where they basically 3D scanned the tree forks, so trees in the forest that have a Y fork in them. And they created a catalog of all of these. And then they only cut down the precise trees that they had input into their design. And so it basically went through all of the trees in the forest and said, we want this. They cut those down, and then they built unique joints with robotics and computation as a means of putting together this really sort of intricate roof structure. You can use things like recycled aluminum now, which would be very difficult in architecture because it's unpredictable, because you don't know what's in the aluminum. And so this is incremental sheet forming by Paul Nicholas. And basically they created this really sort of large scale structure. This also integrated machine learning. And so as it was creating these sort of divots in the aluminum for structure, it was also double checking it against a digital model in real time. And if the scan came out with too much tolerance, basically the computer would redesign it on the spot, and the person doesn't have to keep redesigning based on tolerance. You can 3D print in space now, like Joris Larman and MX3D, and their Dragon bench from about a decade ago. So this is like a really beautiful series of benches that were spatially 3D print using a robot. This is their latest 3D printed bridge in Rotterdam. It's the largest steel 3D printed bridge over the smallest canal in Amsterdam, I believe. Or you can begin tying these systems together. And so this is a project by the University of Stuttgart's Institute for Computational Design. And basically they have two robots on the side of either side of this large structure. And the carbon fiber is basically being flown from one side to the other to extend the reach of the robots. And there's a series of sensors on the roof that tell the robot where it is within space. So the scale of these things and how we make in architecture is changing. So from large scale 3D printed structures, from branch technologies, to like making with all different new types of materials. So another thing here is how form is changing within architecture through these materials. And so the University of Stuttgart's doing a lot of large scale work with carbon fiber. They've been doing a lot of super interesting pavilions. So this is their 2013-14 demonstrator pavilion. This is their 2014-15 pavilion, where they inflated a giant dome, and the robot is basically pasting the carbon fiber onto the inside of that dome. So again, really minimizing the amount of waste that goes into the construction process. The incremental sheet forming of Paul Nicholas's group. So here you can see the robot scanning the metal to see if it's in the right place. And then this is the final structure for their first project. And then they took that stressed skins and they took it one project further with this project, A Bridge Too Far. And so you're able to take these really thin materials that wouldn't be structural prior and make them into extremely structural materials. This is a project by Roland Schnooks that looks at 3D printing and architectural technologies. And so this is a false work. So basically it's a skin that's printed with a plastic, and then it could be filled with something else like reinforced concrete or something like that. And that was a wall for their Sensi Lab studio project. Or even rethinking printing in general, right? So instead of printing in lines, printing using voxel-based methods, such as Manuel Jimenez Garcia and Jules Retson in their series of voxel chairs. And so each of these is printed in space using a voxel that they defined that basically aggregate together in different ways. Getting into robotic architecture, so looking how things are changing more architecturally and how they're made. This is Joris Larman's first robotic project where they were looking at folding folding chairs using robots. So basically you can create a design, send it to anywhere that has the robot set up, and then it can basically be folded into place on site. So you don't have to send things all around the world. This is their butterfly screen that led up to the bridge that we looked at a second ago. So this is their big bridge. Looking at, again, rethinking the design process. So this is a 3D scan of a space. We can see the bricks that are being laid, that have already been laid below, and then the robot with the bricks above. The thing that's interesting here is that like you could change what's happening above that's already been laid, right? And so the design process doesn't need to have to stop once you start making. You can keep modifying as you're going. And here you can see this is another project that Gramazio and Kohler's research worked on. this where basically the robot bends the concrete rebar, and then the concrete is placed directly in the rebar. So you need zero formwork. So this is a zero formwork concrete structure, which can allow them to create really sort of flowing structures that have almost no waste in the production process. So they just sort of pump the concrete into this, and they formulated the concrete so it doesn't sort of slump out the bottom. And getting into sort of robotic spaces. So this is a project by Wes McGee and Kathy Velikoff at the University of Michigan. It's a robotically 3D printed piece that is a robot, so it can actually change its form when people go into it. To the Breathing Wall project by Banaz Farahi, which is a wall that can be controlled through like cell phone gestures. To her, Banaz's more recent work into like wearables that can sense the people around it and basically interact with them. And so this is caress the gaze. And depending on where somebody is looking, if your eyes begin to wander, basically the garment begins to change its shape and become more defensive. And so finally, thinking about futures of robotics. So where are we going? Well, robotics is about more than just, or these digital technologies are more than just about robotics, right? Thinking about new materials. And so this is a project by Skylar Tibbetts at MIT, looking at 3D printing within a gel substrate. So there's zero waste, zero scaffolding, and you can pass through the things you've already printed to tie other things together. He's also working with this with metal. Two materials that are printed on flat that then when you take them up or put another sort of humidity or electricity or heat, basically take on a predefined computational form. And so this was a flat piece of fabric that had material printed on it. And then when it was cut off of the bed, it basically took the predefined form. Two, using things like biomaterials. And so this is Neri Oxman's work looking at chitin as a natural sort of material for 3D printing with the robot. And so basically this giant thing is printed flat. It curls into its predeformed shaped by an external sort of force, be it, I'm not really sure if it was, I kind of forgot whether it was humidity or something, but basically it takes that form and then it's completely biodegradable. To other things like living robots that basically attach to your building. So instead of having blinds, this was a project by Martina Decker, where she created these soft fritz that would go on the glass. When the sun came around, they would inflate and they would suck in the daylight. And then when the light went, like when it got darker, they would shrink and then they would glow. So they have a phase change material in there that basically glows after once it takes in the sunlight. Soft robotics again are really interesting. To living spaces like Philip Beasley's work, where he creates these really sort of complex installations that you inhabit. And the interesting thing about Philip Beasley's work is that he's trying to create spaces that want to learn. And so if you do the same thing to the space over and over again, it gets bored and then won't interact with you anymore. And then this is a robot by Mike Silver, which is an assistant for a brick mason. So basically it's a Pez dispenser for bricks. And it will basically do all the heavy lifting, which allows more people to be master masons. And then Mike always jokes that at the end of the day, you can load it up with this, like a 12-pack of beer and it'll bring you beer. So after a hard day of laying bricks. And then just like, again, getting back to representation, this stuff has no boundaries. We're not just talking about architecture here. Some of these people like Kendra Bain, they go from architecture into movies. And so Kendra started at the University of Michigan. She went to a place called Bot and Dolly, which was then bought by Google. And they basically found ways to integrate robotics into movie making, which allowed for the complex movements that happened in the movie Gravity, which was so long ago now that nobody probably knows it. But it was kind of groundbreaking when this happened because there were all the cameras were on robots, all the people were on robots, and the backgrounds were on robots. And so it was this choreographed, this really choreographed thing that was extremely complex. But from architecture, you can easily move to movies, you can easily move to art. Like that's why it's so interesting to work with all these people from different backgrounds now. And then finally moving sort of beyond Earth and into Mars, because like I mentioned before, we all like to talk about going to Mars, right? But it's not that easy. And we can't just go there and build stuff. And so if we're going to do it, we're going to have to send robots there first. We're going to have to use digital tools to design these things. And we're really going to have to sort of learn from our mistakes, because it's going to, like, just like the SpaceX rocket that, what are they on, number 15 now, that keeps like not landing, right? The same thing is going to happen on Mars as well. And sorry, your brains might be melted now, but that's the end. So the important thing to just remember is that all of this stuff is at its infancy, right? In all the disciplines, we're still so far, like, we're at the beginning. And so where all of this goes and what it leads to, I think it's really sort of, it's I don't know, for me, it's inspirational to think about where things could go. They can redefine craft, they'll redefine the discipline, and they're definitely going to redefine our daily lives, right? So thank you. And 44 minutes, I hope that wasn't too long, Dan.
No, it was just fine. That leaves us 20 to 25 minutes for conversation. I will shut off the recording, and if everybody who wants to may turn on their cameras and we can chat.